Howdy guys, this is a follow-up on this video 3 of the construction series of the 8x8 GSC cell. As well as a common ducted cell. It can be either way. That's why I chose this methodology, is because I wanted it to give options out there, and without having to buy another cell and blah blah blah. You can do all this with one design. It's just a matter of changing the gaskets. But at any rate, I want to talk today about the jig that I use for cutting gaskets and how I laid that all out. Okay, from the very first video, we talked about this plate. This is a jig that I use to drill the holes for the plates for the electrolyzer. Okay, I use that same jig to cut the gasket because it's the same dimension. Now here's an end plate gasket, and it's cut to match that because that's what the plate is. It's the same as the plate, and the gasket's the same dimension as the plate, except it's made out of EDPM rubber and with the 4 holes. Now the next thing I did is I took an old cutting board. I had this, the wife's going to shoot me, but anyway, I stole this from the wife here a while back, and I took the board and I laid out this plate on the board someplace. I just kind of centered it, roughed it in, staked the holes, okay, and marked it on this, drilled them 7/16, tapped it to 1/2 inch, and I took bolts and I cut the heads off the bolts, and then I also took most of the threaded area off the bolt with the saw, and then I took 2 1/4-inch bolts and cut them off. The same type of scenario, made pins out of them, or guide bolts. Some of the guys may be familiar with those, of the fixture. Now the only modification I did to this particular plate is I drilled these 2 holes. And the idea of that is to lock it in, and I'll show you. Now this is referenced, I have an arrow here like from before. I utilized that arrow, but here on the end of the cutting board I made a notch, so that tells me which way to orient this plate, so that way when I do my repetition everything will be the same, or as close to it as I can get it. So basically it all just kind of sits on there. It never fails. Anyway, it fits on there. And what you do is you lay this plate, this template, on your gasket material, your bulk material, and then you scribe around the perimeter of it. Take a center punch, blind hole punch, and what that is a punch with a little nipple in the end of it, or tit, like a center punch, and it fits the diameter of the hole and then also gives you the center of the hole when you hit it with a hammer. Stake your holes. And I do that in 4 corners with 1/2 inch, and then the center holes I did the same thing but with a 1/4 inch size. And that's what that does. That dimples the rubber, puts a little dimple in it, and marks it so you can see it. And then you take your gasket cutter, and it can be done on this board or on a piece of plywood or something, but don't do it on bare metal. It'll dull your gasket punches. Takes the edge right off of them. And what you end up with is a gasket like this, except in this case this one doesn't have the holes because this is an in-plate gasket, but it would look like this. I'll just show you. You take it out of here. You'll end up with this. You have your 2 holes for your guide pins and then 4 more holes around the perimeter. So we lay the gasket onto the fixture. Let's see what I'm doing here. Like so. And you take, after you have that in place, now this is kind of a hurried up job. I'm usually more careful. I make sure things are lined up correctly, and I pushed all this down with take a piece of hose or something that fits this diameter, and you kind of push down on this to get everything pushed down tight. Then you take your plate. Now this plate is also witnessed. I have a reference mark here, just like I did on this one. This fits over your gasket, just like that. That's what these 1/4 inch bolts are for, or pins. Just to lock that plate in. The gasket is locked in by the pins. as well as the 1/4" bolts, and then this scribe plate is locked in. And then you take your trusty tile knife, and be careful, and you basically just scribe around this. And now, one thing that I try to do is when I'm scribing, I'm very, very careful. I'll tip it up the edge right on the corner, and then I, of course, draw it down. And then when I get to the end, I'll tip the knife so the blade is vertical. I end up with a square cut. But then I always try to start at the corner and draw it to the metal. And why I do that is sometimes, you know, things get grabby, and you don't want this to slip and go that way, because if you do, you end up cutting your gasket, and then consequently you wasted a gasket. So be very careful when you do this. Anyway, you scribe on down and just do the whole perimeter. Once you got that complete, you can start lifting the gasket. And there'll be areas that you missed with the knife. You can take another type of an X-Acto knife, or you can use just a plain utility knife and carefully trim those sticky points that you didn't quite get cut. And then when you're done, you can just remove the plate, and you end up, let me get set up here for you. I'm a lousy cameraman, by the way. You end up with a fixture. You'll have your inner gasket. That'll be left. And your outer gasket, where you did your cut. You simply just lift it off, and okay, this part of the gasket phase is complete. At some point later, we'll be cutting notches in here, okay, for the gas splitters, and that's all referenced off the drawings. So, that's pretty much it on that. Main thing is lay out accurately, and if you got this original plate done correctly and accurately, it's a breeze, because all you do is you reference this just like you did when you staked the electrolytic plates. Everything's going to be the same, and then get a set of blind hole punches, and you can get those through Harbor Freight pretty cheap. They're very handy. I would recommend anybody that does any type of work with drilling holes and has to line up a hole or something, get those blind hole punches, because they save a lot of time, and they make it a lot more accurate and easier to do your job. At any rate, don't get the wife mad by stealing her cutting board like I did. One thing I did do with this board that I took a piece of plywood and I added to it. I cut a piece and I screwed it, drywall screws enough to secure it. I wanted this real rigid. I didn't want it moving around on me. So I did that. Now I'll save this because more than likely I'll be building more of these cells. And maybe one of you guys will want me to build you one. I don't know. We can, if that comes into play, we can talk about that at some point in the future. But first off, we'll get this one complete. Hopefully get you guys on the same page and understand how it all works. And we'll go through the testing phase, and we'll talk about that and how I test and the measurements I take and how I go about that. I want to cover that so we kind of get a better understanding for you guys out there that have questions. And there again, some of you guys that have been doing this for a while have recommendations. By means, I'm no expert by any means. I mean, I've got experience. I've been doing this for about 10 years, and I understand materials engineering and all that stuff. But hey, you guys, I don't know how many times I've learned things on projects or in the field from a novice. They brought up a question or make a statement, and I learned something. So hey, I'm out here to learn just like you guys are. So there is no experts. We're all students, and we're all here to learn. Some of us have a little more experience than others, and that's cool. That's just the way it is. So if we can help each other out and contribute and make things work and try to, go for that common goal of making a very, very efficient electrolytic cell that splits the gases or doesn't split the gases, depending on how you want to set it up, that's what we want to do. And maybe we can take this design, and with your guys' input, we can even take it to a higher level than it is now. Right now, it runs as efficient as any other well-made electrolytic cell. Now, there's been some discussion on the working water card group about, cell designs and efficiencies and gas cells that produce better gas than other cells. And yeah, well, there is some truth to that. Obviously, it's just a design issue and maybe some material choices. the setup of the plate spacings. There's things, electrolytes and blah, blah, blah. It kind of goes on and on. The point is the idea of this is to show you folks how I build cells and how I can produce one that runs as efficient as the state-of-the-art today's technology electrolytic cell. Right? Now, I have holes in my plates, right? And these plate holes are for fluid transfer and fluid transfer out. Otherwise, transfer in, transfer out, gas out. In this case, hydrogen or oxygen. They say, well, when you run a convection cell, you have parasitic losses. It's not a total isolation cell, as like what SMAC has with this titanium. But the thing is with this design and the way I got it together is when things are compressed down, the gaskets are compressed on both sides. The gasket actually swells around this hole. Now, this is a little trick, okay? It swells around the hole and seals off the edge of this inner edge of this hole. And what that does is that stops parasitic electrical losses, or greatly reduces them. Maybe not 100% stoppage, but greatly reduces them. And that brings up the efficiency of your cell. There's some folks in Australia that are working on a cell. Basically, it's my design. They evidently had been working on one too. Anyway, that's a long story. But anyway, it's you look at it. I could probably hook you up with a link on it. But it's the same cell as this cell, except their membrane's different. Their gaskets or their plates are scalloped. And it looks like a pretty good unit. They have some learning issues too. Hopefully we can work together and kind of resolve some of them for them, and how to bring up the efficiency of their cell. They're having a few problems, and that's it. We need to work it out. We need to work together and figure it out and make it best for everybody. So that's the point here. It's a common knowledge stuff. So everybody that's interested in doing this can learn how to do it correctly. So we don't end up with bad cells and disappointed people, and we don't want that. We want everybody to try to get the best stuff that they can get out of it. So anyway, I'm rambling. I'll shut up, and I'm going to cut some gaskets, cut some more of these guys out, and when I get that complete, then we'll be doing another video on me cutting out those corners and kind of explaining how the membrane is going to be cut. And there again, see, the membrane will be based off this dimension. I'm rambling again, guys. And that's what this is you lay this down, and you use a soldering gun with it sharpened to a knife edge with a file, and you go and cut the perimeter. It welds, seals the material that I use, and there's no fraying. It's really straightforward, and it's cheap. That's hard to say for these days because you know how everything goes up, or has gone up, and it's probably going to be going up even more. But anyway, I'm going to shut up and end this video, and we'll talk more about the gaskets in the next one. So talk to you guys later.